In this video, I'm going to show you how to cache data with Retrofit. So how to look at responses, how to request responses from a server or a REST API or something, and then cache those responses so that they can be used when the network goes down or if the app goes offline for some reason. So this is kind of a long-awaited video. I know a lot of people have been asking this for a long time. So hopefully I can shed some light on how to use retrofit caching. And I'm also going to be talking about why I personally think you should almost never use retrofit caching. So why it's basically inferior in my opinion, and why you should almost never use it. I really can't think of a situation when you should use it as opposed to using SQLite and the room persistence library to cache data. But I'm going to talk more about that later in the video. Just to get started here, I'm going to start with a demo which I have on the screen here. Okay, so as you see on the screen, I have an app here. This application has access to a REST API, so it can query information from the internet from this REST API right here. It's free. You can just go to jasonplaceholder.com/typecode.com. There's a bunch of different places you can go. They have posts, comments, albums, photos. Basically, it's just dummy data that you can get, and you can use it for your applications. So it can query this URL right here, which is just a list of 500 kind of randomly. I think it's 500. Oh, it's only five. I think it's 500. I didn't count, and I think it says, but anyway, it doesn't matter. Bunch of data. It's just a big piece of raw JSON data. It also has the ability to search particular photos. So if I change the ID of a photo in the URL, it will get that particular photo. So let's take a look at the demo here. So if I type photos, it will search that URL that I just showed you, which was this one right here, and it'll get the big list of photos. So notice the application is online. I have the network online. If I click search, it will then retrieve all of those photos from the REST API. If I was to search an individual photo, say photos/1, press enter, it will get that first photo, and you can see that it matches that first list entry, which is this one right here. If I was to search number 2, which we expect to see this purple 600 by 600 one, so if I go /2, we see that purple 600 by 600 one. So because I've made those two requests, they've been cached. Retrofit has cached those requests. So now watch what happens when I turn the network off. So I'm turning on airplane mode, and I'm going to make those same requests. So if I search for photos, there is the list of photos, same thing. Network's off, everything's working as it should. If I search for the first one, which we also queried, that's also there. Great. But now here comes the limitations of when you use retrofit for caching. So you expect that because I queried this entire list of photos, these are all cached now. You'd think that I should be able to get pretty much any one of these photos. But if I go to one that we didn't specifically search, like photo number 3, if I search that, I get nothing. And that's kind of the biggest downside to using retrofit caching, is because the way it works, it stores key value pairs. So it stores the specific request as a key, and then it stores the response as the value. So only if the response matches exactly what I searched, then you can get that cached response. And this is a pretty massive limitation when it comes to any kind of advanced functionality with your applications, because chances are you want your users to be able to search your app for certain things. Like on Instagram, you can search different users, different posts, different hashtags. If you're familiar with my database cache course, I'll just pull that up. That's Food Recipes app right here. This one, so if I turn off airplane mode and I was to execute a query, say search for some chicken, the network's on, so all of these are going to be cached now, all of these chicken recipes. Now if I turn off the network, first just make note of this Cajun chicken pasta title. If I turn off the network and I search for Cajun chicken, just do Cajun chicken, I still get some data. So even though I only searched for a particular category, I can still find specific recipes by searching for different keywords. So that's like the advantage, or one of the advantages of using Room. Room and SQLite is you can take advantage of the advanced search functionalities that exist with SQLite. And with Retrofit, you can't do that. All it does is cache the raw kind of request, and then the raw response. And it's a key value pair system, so there's no in between. There's nothing advanced you can do with it. So a pretty big, pretty massive limitation in my opinion. And then of course, you get a massive kind of data overhead because you're going to have all of these key value pairs with the raw data. Like if I was to pull up the REST API and I go to the photos, if I'm querying these photos, it saves this request as the key and then this entire thing as the response. So all of that data is getting saved. And that's only one key value pair. It's just a very primitive system. I think it's not, like I said, I can't think of any situation when you'd want to use it, but in this video, just in case you want to know anyway, I'm going to show you how to use it. So let's take a look at the example. Okay, so I'm not going to be just kind of coding this all up right now because I don't really see a lot of value in it. I want to focus on just the retrofit caching and not like how to set up the recycler view, how to do all the other stuff. So I've created a repository ahead of time. Just go to my GitHub. Link will be in the description of this video. Retrofit caching example. Just go clone or download. Get the repository URL right here, and then open Android Studio. So I'm opening up Android Studio here. I'm just going to minimize that, and I'm just going to clone this repository, and then we're going to go through it, and I'll talk about how to do everything. So I have the URL copied. I'm going to go to checkout project from version control. Go to Git, I'm going to paste that in and click clone. And now Android Studio is going to build the project and get ready for me here. All right, so there we go. We have the project. I'm going to go into first. I'll just kind of talk about the code briefly, just so you have a sort of an understanding of how to do this. But obviously, I expect you to know how to use Retrofit, how to set up recycler views, I expect you to know things before learning about retrofit caching, because unless you already know how to build apps, sort of, anyway, you've watched some of my videos, chances are you don't want to be learning about retrofit caching. So anyway, there's a couple kind of main classes in here. First one is the My Application class. It just extends application. So it's a class that starts when the application starts. And basically this is just used to retrieve whether or not the network is connected. And we're going to be using this Boolean later in the service generator class, which you'll see in a second. So I just wanted to make you aware of that class. Main activity, actually we'll go into the API class. This is for the two requests that we make. One is for searching a particular photo IDs, so photos / their ID. The other one is just for searching photos. So if we look at the JSON API, that'd be like this URL compared to this one right here. So those two different URLs, that's all this is right here. Next let's look at main activity. So main activity, pretty straightforward. We just have a search view. As you saw in the app, there's a search view up top, collapsing toolbar, which I just added because I think it's easy to add and it looks nicer, no real reason. Got the recycler view adapter. Then we have this service generator class, and this is where the retrofit instance is, and all the networking stuff that we're going to take a look at. So there's nothing really special in main activity. It just has like a single method called search API. The logic in here isn't really important. If you know how to use retrofit, this is going to be very familiar with you. Nothing surprising. It's just like basic. Just executing the query using a basic callback, basic enqueue. You get the response. The only thing here is that I would want to point out that this kind of if statement right here. So the way this works is if there is data coming from the cache, which is determined by this if statement right here, coming from the network, it will tell you that the response came from the network, as opposed to if it came from the cache, it will tell you that it comes from the cache. And we're going to be taking a look at the log outputs later, so I just wanted to kind of point that out to you. It makes it obvious when you're looking at the log where the data is coming from. Okay, so the final class here that I want to talk about is the service generator. So this implements a singleton of the service generator class. If you know how to use Dagger, you obviously don't need to use singletons. You can just use injection, but some of you might not know how to do that, so I used a singleton here. Just creating an instance of the service generator class. Again, you should be familiar with this. If you're familiar with my videos, you know how to use Retrofit. All this stuff shouldn't be new to you. This is a beginner video, so I'm not going to get into the details of that. So here, the first thing I want to point out is this variable known as cache size. So this is the cache size. I set it to 5 MB, 5 megabytes. That's the first parameter that I want to point out. Next is the Retrofit instance. So again, if you're familiar with my courses, you know that typically when I use Retrofit, I build a Retrofit instance. And we're going to come back to this, but the parameters here I want to point out is the base URL, which accesses the JSON placeholder API right here. Should be no surprises there. The client, which we're going to come back to. The converter factory, which converts the JSON data to Java objects. So you should be familiar with that if you've used Retrofit before. And that's pretty much it. So now let's talk about this OK HTTP client. This is where all the properties go for the caching. So if you look at the OK HTTP client builder here, we have the first parameter is the cache. So I'm passing this builder method right here for the cache. So I'm going new cache, saying new file, using my application to get the context, getting the cache directory, specifying a file name. I'm just calling it some identifier. You can call this anything. Like it doesn't matter what that is. It's just an identifier. And then you're passing the cache size, which is the property that I passed up here. So that is how to define a cache object that you then pass to the OK HTTP builder. Pretty straightforward, nothing sort of crazy there. So now we're getting into the tricky stuff. So the first thing is the Retrofit uses, or you can use these things called interceptors to log things, in this case, we're using it for caching, or to basically make changes to requests before they become available to the app. So they're called interceptors, and the name is really good because it's an interceptor. Basically, you make the request, the interceptor intercepts the request before it makes it to the app, and then you can make changes to it and it gets sent to the app. So it intercepts the request before it's sent to the app, basically. And the first interceptor that we're building here is called a HTTP logging interceptor. And you need a special dependency to use this, which I should have pointed out at the beginning of the video, but I forgot to. But anyway, let's go to the build.gradle file. So you need to use this OK HTTP logging interceptor dependency to use logging interceptors. And the naming is good here. It's very obvious what this does. It intercepts the requests and then gives you extra information about that request. So it's for logging, basically. If I scroll down and I go down to the HTTP logging interceptor, it's just very simple new HTTP logging interceptor, and I'm using a new logger and just printing out whatever the log output is, basically. And this is going to give us more information on the request. You can use different debugging levels, like there's basic, body, headers, whatever. I'm using body. But this video isn't on interceptors. If you want more information on those, do some research. But basically, they're just to get more information about the HTTP requests that you make with that retrofit, and you can print it to the log. So next coming up here is the network interceptor. So this one is this is used, or we add this interceptor by calling the add network interceptor method. And this interceptor is special because it's only going to be used if the network connection is available. So if the network is down, this interceptor will not be used. So now let's come down and take a look at this. So if I scroll down to the network interceptor that I have right here, I'm just going, new interceptor, and implementing the response or the intercept method. Then inside here, we set some properties that have to do with how we want to cache things. And remember, this interceptor is only going to be called when the network is available. So what we do is we get the response. So we get the response from the server, and then we make some changes to it before sending it to the app. So we go chain.proceed, chain.request to get the response. And then we create a cache control object to change some options that have to do with the caching. So we go cache control equals new cache control.builder. We set a max age parameter. I'm setting it to 5 seconds, and then calling build. And what this is going to do is it's telling OK HTTP to cache this request for only a maximum of 5 seconds if the network is available. So before I talk about what's going on down here, let me just do a demonstration so you understand what I'm talking about. So I'm going to turn the network back on here, and I'm going to open up the logcat so you can see. Looks like it says my app's not running. Let's just run the app again here. Okay, so we have the app running here. I'm going to filter on, oh no, I don't want to filter on service generator. I want to filter on main activity. And let's bring up the app, and I'm going to make a request. So the network is on. I'm making a request. It doesn't matter. Photos/1. Let's make that request. Put this over here and take a look at what it says. So notice that it printed twice, by the way, because I hit enter instead of hitting search on the app. So don't worry about that. But so it says, the important thing here is that it says the response came from the network. But now watch what happens if now that I've waited more than 5 seconds and I make that request again. Again, it goes to network, but now watch what happens if I do it quickly. It says it comes from the cache. That's because I made that request in less than 5 seconds, which is what's happening right here. So if the request is executed in less than 5 seconds, instead of doing a network request, it just retrieves it from the cache. So this is a way to make your app more efficient, basically. It's saying, typically you don't need to do another network request if you've already done one not long ago. A more realistic number might be 5 minutes, honestly. In most scenarios, you probably, like, unless you're dealing with like a real-time stock application or something like that that needs data updated all the time, you're probably fine to do like 5 minutes. And in some cases, you can use days or even months for data if you don't think it's going to change. So that's what this does. It's kind of like the when the network is on, should it use the cache or should it not use the cache? If it should use the cache, how long should it wait until it should? So that's what this parameter is. And once again, that's in the network interceptor. So this one is only going to be called if the network is available. So now let's talk about what's happening down here. So we're returning a response.newBuilder, and we're returning a response object, but we're applying some new properties to it. So first, I'm removing this thing called this header pragma, whatever that is. I'm removing a header cache control, and then I'm applying a new header, which is from that cache control object that we just got. So now what are these two things? This I'm sure is confusing you. I didn't explain it, so obviously it's confusing you. So this header pragma thing, it's a header that's defined as, for example, I'll just scroll up to the top actually because it's defined. So here's the constant right here. It's just this pragma. It's a string. It's a header that's attached to HTTP requests. And what it can do potentially in some cases is it can basically tell the request not to use caching ever. So we want to remove that because in our scenario, we want to use caching, so it's better just to remove it. We don't need it. We can remove that header. The header cache control is the header that defines the cache control. So in every request, in most requests anyway, there's going to be some kind of cache control, some default cache control that comes from the server when you make the request, and it will have the header cache control. So what we're doing is we're removing the header that comes from the server, and we're applying our own header, which is the one that we defined right here with the cache control object. So removing the pragma thing, removing the default cache control from the server, and then we're applying our own cache control right here, and then we're building it and returning the response. So basically that's how caching works with Retrofit. It's that easy, very simple to do. That's online caching anyway. So now that we've looked at what's going to happen in the situation when there's online caching or when the network is on, what's going to happen when the network goes off. So I'm going to go down here into our OK HTTP builder again, and we can look at the last interceptor, which is this offline interceptor. So I'm going to scroll down here and we'll take a look at this. All right, so this interceptor is just pretty much the same as the network interceptor. The only difference, or the main difference, I guess, is that it's applied using add interceptor as opposed to being applied by using add network interceptor. So this is going to get called, this interceptor will be called if the network is available and if the network is not available. Because of that, I'm applying I have an if statement in here, checking to see if the network is available from the myApplication class, which is this method right here that I talked about at the beginning of the video. So if the network is not available, then I want to apply some custom caching. So same kind of thing we did in the network interceptor. We're removing the pragma, we're removing the default header, and then I'm adding some new cache control to add caching. And actually, there was something important that I didn't point out here. So, no, I did talk about this. In the network interceptor, the max age property is the one that we set. But in the offline interceptor, I'm using max stale, and I'm setting it to 7 days. So what this is going to do is it says, basically it says, check the cache if there is data in there, and that data is newer than 7 days old, then you can use that. So the first check is the network offline? Yes, it's offline. check the cache. If there's data in the cache that matches the request and it's less than 7 days old, then we want to get that response. And that's pretty much it. That's all there is to retrofit caching. If you were to copy this exactly like I have, both the interceptors, apply the cache, the OK HTTP client, you would have retrofit caching working in your application. So the good things about it is that it's super easy to use, as you can see, obviously. Very easy to set up. It works okay, but it's really inefficient, and it lacks a lot of functionality. Like I said, if we take a look at the REST API MVVM app that I built, let's see, in my local database caching course. If you are interested in taking that course, by the way, where I show you, in my opinion, the best way to cache data, and pretty much the only way I think you should ever cache data on Android using SQLite and Room, it's going to be this course right here, REST API with local database cache with REST API, this one right here. This will show you how to build a database cache, a local database cache properly, basically, which is the one you see in this app right here. So if the network's on, I can, search some categories. Doesn't matter what category, I'll search for breakfast. Now all this stuff gets added to the cache. Cool. I can click on recipes, take a look at them, see what their ingredients are. There's pagination. So if I scroll to the bottom, got that loading animation, it loads more. Lots of features, and the best thing about it is if I turn the network off and I perform any kind of a query, I'm just going to say oatmeal, sure, then I get any of the recipes that were cached that contain oatmeal, whether it's recipes or it contains the title. I can search for, I think we searched breakfast, so if I search eggs, that will probably return some results. So you get a whole bunch of responses. And retrofit, if you cache with retrofit, it's hugely limited. You can't take advantage of any of these advanced searching features. So I pretty much recommend don't use it, but I'm sure some of you will. But anyway, that's my opinion. Trying to think of anything else. I think that's pretty much it. It's obviously a very quick overview. If you don't know what retrofit is, you're probably going to struggle a bit. But that's it for this video. Once again, if you want to learn the proper way to cache data, check out my course. I'll see you in the next video.